Hello and welcome to my channel. Today we are going to see how we can calculate the resistance needed for a simple electric circuit that consists of a LED light and a constant voltage. My circuit consists of constant voltage of 5 volts, one red LED light, and here I'm in doubt if I should use a resistor and what is the value of the resistor. And here we should start calculation. Once you did the calculation, you will know forever. So, let me draw the circuit first. So I have a 5-volt source. Here I want to know if I should add a resistor. And here I have a diode. So my circuit currently is not connected. But what do I know? If I go to a datasheet of this diode, because every producer has its own datasheet, but let's say that these are standard. So for a 5mm LED light, it's very usual for them to have forward voltage of 2 volts and a current required to flow through of 20 milliamps. This is very standard thing. But if you're in doubt, or especially if you're doing a very professional project, you should always check the datasheet of the manufacturer. So, because we know that the current that needs to flow here, it's 20 milliamps, it's the same current that will flow to the resistor. So we know that the resistor will have also 20 milliamps of current. We know the voltage of the whole system. So from here we can start the calculation. Let me take this here. So we can use the most used law in electronics, which is the Ohm's law. So we know that the voltage equals the current times the resistance. Very simple formula. And from here, if we apply some algebra, we know that the resistance equals the voltage divided by the current. In our system, we have two voltages. One is the voltage generated by the source, and one is a diode, which is taking voltage away from the system. So we decrease the forward voltage, and we divide it by the current. So in this case, we have 5 volts minus the 2 volts that we found from the manufacturer's sheet, divided by 20 milliamps. We have the resistance needed equals 3 volts divided by 0.02 amps. This way we will have ohms. So we don't need to use calculator because this is equals 300 divided by 2, which is 150 ohm resistor. So basically for this circuit we would need 150 ohm resistor. Here I have exactly that, 150 ohm resistor. So I will take one of them. These are very common, and I will add it. It doesn't matter if you add it before or after the LED light. So I will add it, and so I close the circuit. So now we have everything calculated for the circuit, and the circuit works perfectly. This way we are sure that we are in the limits of the LED light. Just by doing these simple calculations, or just by watching this video, you would know that from now on, if you have 5 voltage of current, and if you have a standard red LED light, you would need to use 150 ohms resistor. And with this you will prolong the life of the LED light, and it will work as intended. So basically you should know that that all lights don't have the same, don't need the same resistance. Because basically we have here, we have different kind of LED light. I have here a red one, yellow one, green one, white one, and a blue one. Basically the red one, the yellow one, and the green one, and also the orange, you can find the orange. It's not that common, but you can also find it. Are quite similar, meaning that usually for a 5mm standard, but it has a forward voltage of 3 volts, which means that we'll need a resistor of around 100 ohms. The blue one has a current requirement of 30 milliamps and has a forward voltage of 3.4 volts. So it will need a resistor of about between 60 and 50 ohms. The LED lights these days are quite flexible, so if you don't have 150 ohms for the red light, and if you put 4 resistors in series of 40, which will make 160, it will work the same. It doesn't have to be precisely 150. It is better to be, but it is not that important. But the most important thing is to see the maximum voltage from the datasheet and not to go over that voltage. Because if you go over that voltage, your LED light at the moment will not show any difference, but it will decrease the lifetime of the LED light. So it's important to be below that threshold of maximum voltage, which for the red LED light is 2.2 volts. So that's it. You can use this calculation for any circuit everywhere you need to insert an LED light. And with that said, I hope you find this video useful. And if you liked it, don't forget to click on the like button and subscribe to the channel. Thank you for watching.